All right, so we're going to look at Chapter 11, which is Soils and Media. So your chapter outcomes or learning targets, you've described the importance of soils and media in horticulture, describe the factors that shape the formation of soil, describe the physical properties of soil, and then describe the biological properties of soil. They also have identify the chemical properties of soil, compare and contrast soil and soilless media, describe inorganic and organic mulches, discuss containers used in horticulture production, and discuss careers related to soil science. So what is soil? For most of us, we're like, it's that stuff on the ground. Well, there's more to it than that. If you look, they have a nice little pie chart here for you. So you have 0 to 5% organic matter, 45 to 50% mineral, 20 to 30% water, and then 20 to 30% air. And this is showing you on this half, this is all the pore space, so the space between the soil particles. And then this half is all of your solid pieces to the soil. So soil forming factors, you have weathering, climate, organisms, relief, parent material, and time. So weathering is the physical, chemical, and biological process that creates soil. Climate is the weather conditions, including both temperature and rainfall. Organisms are microorganisms that break down organic matter. Relief, an environment where the rocks and soil sit on the landscape. Parent material, that's basically the substances underneath the layers of the soil that it's created from. And then time, the length of time during which soil is formed, impacting soil composition. So there's your horizons, and this is something that I always tell kids. I don't know if you were one of those children, but I was one of those children that, I'd kind of pretend to dig to China. My parents loved me so much. But I remember vividly as a kid, when you would dig in the soil, you would get down far enough where the soil color would change. And that's basically, if you look at this is a little extreme on that digging to China piece. If you were ever doing construction, you would see this. This would be like if you dug out for a basement. You can see here's plant life up here. This portion here where it has a horizon, that is your fertile outermost layer of soil, also referred to as topsoil. And then if you look here, this whitish layer is going to be that B horizon. That is the subsoil layer, which contains much of the original parent material that has been weathered. And then C, you have even further down here, the subsoil layer. And that contains much of the original parent material that has not been weathered. So soil texture, you have the water holding capacity, obviously how much water it can hold. Aeration, the process by which air is circulated. If you think about it, my plants I'm planting in the soil, they need air at their roots or they're just going to rot. Drainage rate, basically the rate that water passes through the soil. Compaction potential. This would be a big factor in our field crops where you may have a big tractor driving on it. And even in our little gardens, if you're walking on it when it's wet, you're going to compact the soil and make it harden together. And then erosion potential, that's how easily the topsoil is lost through erosion or tillage after rainfall. And then nutrient retention, the ability to store plant nutrients and resist pH changes. So you have, if you look at the textural classes, you have sandy soils, clayey soils, and loamy soils. And obviously, if you look, they're basically dominated by this soil texture, which we'll get to. When you talk about loamy, though, it's an even mixture, and this is really well liked by agriculturalists. Even mixture of sand, silt, and clay, moderate water holding, strong nutrient holding. It's basically ideal for what we want to do with our plants. So determining soil texture, which you guys will do, this is basically doing the ribbon method, and I'll show you how to do that in a different video. And it's doing this by feel. So it's something you can typically do in the field, and some people get really good at it, and we'll talk about that in another video. So pedologists, there are actually, this is kind of cool, there are soil surveys that have been done throughout the United States just to check out what the soil textures are in our agricultural areas. When you look at this, some of you have seen this before. We do some stuff with this in Exploring Ag. We also have done some stuff with this in crop science. This is your soil textural triangle. Basically, any soil structure you can find fits somewhere on this triangle. If you look at this side, you have clay, percent clay, you have percent silt over here, and the percent sand on the bottom. And you can actually take and do a test at home if you wanted to figure out where your soil would fit and figure out the percentage levels of each particle size. So this is showing you, it says influence of soil texture on properties and behavior of soil. So this is just kind of showing you where it all fits and kind of what to watch for. This is something that Soil and Water Conservation District people really check out. Managing soil structure. You may have heard the term cover crop and compost before. So cover crop, this is a crop that basically I'm going to plant, adds nutrition to the soil, it's going to help erosion. I might just be tilling it back under, depending on my situation. But most places might require you to have a cover crop is what they call it. Basically, you can't leave the land sitting bare. And then compost, some of you maybe do something like that where you are adding nutrients from maybe your scraps from the kitchen or animal manures back onto a field, or in your case, it might be a garden. Soil bulk density. When you look at soil bulk density, they're talking about some different practices that you can do to help keep your nutrients in the soil. So they have listed here no-till, minimizing traffic, mulching, adding crop residues, compost or manure, and then cover crops. There's soil water. So this one, and you look, they're checking a soil moisture gauge in a field here just to kind of see what the level's at. You have gravitational water, it's free water. It's going to wind up in the macropores, and it's not available to plants. It's going to be lower in the soil. Capillary water is held against gravity. It's in the micropores, and that's available to plants. We're not going to get super in depth with that. Soil color is something kind of cool. If you travel throughout the United States or worldwide, you'll notice there's soil that has many different colors to it. Part of it is actually the nutrients available, the natural minerals in the soil. Can be a lot of different things that show up and change the color of the soil. Biological properties. So you can see this lovely image has lots of stuff going on to kind of make us think about what is in our soil. There's lots of living things that help. They decompose, they recycle carbon, add nutrients, and they also help create little pores. These pores actually help air get into the soil much better. This is showing you a list of microorganisms and then quantity per square meter. Some of these you might go, I don't like them so much. And that's okay. Some of them are good in small amounts, and then they can be terrible. Like if I think about snails, slugs, they're things that kind of destroy hostas. Gophers, they dig holes. They do some good things, but too many can do a lot of damage. Soil-dwelling insects, they do improve soil aeration, improve water infiltration, provide nutrients, and you can see there's a list of some examples. This is your lovely dung beetle. You have burrowing organisms. So they do actually provide some space for gas exchange. They move soil. They can enhance stability. Most of us don't like them just for the fact that they make big mounds. They also can destroy roots of a crop. So there's some give and take with them. Chemical properties, you have cations, anions, and then cation exchange capacity, which we're not going to get a whole lot into. This one is showing you a pH scale. Some plants like it acidic, some like it alkaline. Our plants can be very sensitive to the pH scale, which we'll get into when we talk about specific plants. This is showing you optimal soil pH, and it shows you plants. That's kind of what I was talking about, where you can see it. Some like it, more acidic than others. If you're doing a whole field, that's better to kind of take into consideration. Small stretches in a garden, you may not have to worry about it as much. And then there's soil testing. So this is what they call a soil probe. It's kind of like if you were taking and making a hole if you were ice fishing and using an ice auger. It's the same concept with this probe or soil auger. It basically pulls up a sample that they can do some testing on. A lot of them some of them can be up to 10 feet, but a lot of them are short, like this one here is, maybe a foot long. Soil and soilless media. So the biggest purpose of soil is anchoring roots and providing structural support for our plants. Soilless media, if we were in the greenhouse, you would actually see I have some lava rocks and perlite that we can use that does not have soil. These I use in the hydroponic system, which is all water. They do have, a lot of times they're lighter than soil, and they might have more pore spaces, and they should be sterile, so you're not adding any bacteria or other things to the plant. It's garden with native soil. It is fine. I wouldn't use it in containers because you might be adding weeds to that container garden. It can, add pathogens and insects as well. If you look at these are all options of soilless media, which we're not gonna spend a lot of time on. I do have a whole bunch of perlite in the greenhouse that we will check out hopefully at some point. There's some other options here too. And the slow release fertilizer, you're not going to plant all of your plant directly into a bag of that, but you're going to add it to your mixture. Mulch. Mulch, the purpose of it, it looks pretty. It stops weed growth. It retains water, keeps the soil a constant temperature. It can add nutrients, and it is a platform for traffic. And typically you would do maybe 3 to 4 inches deep for mulch. Inorganic mulches, they have some options here. You can do, and I have some of this at home, I have some plastic mulch. Basically, you're putting a layer of plastic down, and it's helping prevent weeds. The thing I don't like about it is that gardener snakes love it. So you have to be kind of cautious with it. And this looks like they're using some sort of rock on there too that you can use for a mulch as well. Some organic stuff, you can use some different waste products. You could also use straw, which is an organic mulch. It does add some benefit to the soil, but sometimes you have to watch. You might be adding weeds if you're not careful. Growing containers, obviously there's many different shapes, sizes. Typically we like them to be lightweight and have some drainage available for the plant. Drainage holes you're going to want so you don't have oversaturated plants. If you've ever left a potted plant outside in the rain and had to dump water off of it because it got too saturated, that's exactly what the problem is. And this is your career connection. You have soil scientists. They also call them pedologists. They map soil, complete soil surveys. They can work for colleges, universities, and private industry. They can also work for the, like it mentions here, NRCS, Natural Resource Conservation Service. So another thing that we are going to be doing is actually doing a soil sample. We're going to do a soil textural sample. You guys will see another video for that. So you will be learning more about soils, just not at this moment. So look forward to that video, and that was your Chapter 11, Soil and Media.